taking place on our ancestry as well. So I mentioned prosimians before, and prosimians are sort of an archaized form of primates. That doesn't mean that they're an ancient creature. They're, like I said, just as evolved as we are, but they split earlier on from our branch. And so prosimians are more similar to some of the earliest primates than we are. These are organized into, as I said, the two types of creatures that have a longer snout and a wet nose and the rhinarium, and those that don't. And those are strepsirrhines and haplorhines. And so you have lemurs and lorises, which are prosimian strepsirrhines, and there's one kind of creature, the tarsier, which is a prosimian, but it's a haplorhine and it has a dry nose like we do. And then there's the anthropoids, which are all haplorhines, and they are so they all anthropoids have a dry nose, and those are monkeys and apes, both Old World and New World, and we are included in that as well. So we're an anthropoid haplorhine. Tarsiers. Tarsiers are kind of funny creatures. They have a body form which is very similar to other prosimians. So they're not anthropoids. They have for instance, their foot their foot bone has the talus bone is the heel bone. We have that as a specially adapted calcaneus and talus, which is our heel. And that's adapted, and it's very sort of compact and almost sort of like the heel of your foot, right? But in a tarsier that's elongated because that same bone exists, but it acts as like a spring, like a frog, to leap from branch to branch. And that's more similar to a prosimian type of a adaptation or morphology. But tarsiers do not have a rhinarium, so they can't be classified as strepsirrhines. They're a haplorhine, but a prosimian. Now, amongst the platyrrhines, there are two large categories. Those are amongst the anthropoids, two large categories: the platyrrhines and the catarrhines. Now, I already mentioned this before. The platyrrhines have broad noses. That's what that word means, flat-nosed, platyrrhine, and have a round nostrils and a wide septum. Platyrrhines are only found in South America today, and although you find them 40 million years ago or so on all continents. At that time, the continents were much closer together. As those continents started to separate, the platyrrhines became separated, geographically isolated. We've seen how this works in evolution. So they started to speciate, and platyrrhines became stuck over in North America, drifted away, genetic drift, and you have no platyrrhines that are indigenous to the Old World, that is to say Eurasia and Africa. Those are the ones that are in the Old World are what are called catarrhines, and we are catarrhines, amongst catarrhines. So the anthropoids that are found in Africa and Eurasia are the catarrhines, and this means means hook-nosed, and so they have, including us, and you have two types of catarrhines. Those are the cercopithecids, which are monkeys, and the hominoids, which are apes. The cercopithecids are of various types. You've got the colobines, which live in forests. They're arboreal, and they eat leaves. And then you have the cercopithecines, which are mixed habitat, and these are both can be arboreal and terrestrial creatures. So things like baboons would be Cercopithecines. You find them out on the savanna. The Cercopithecines have more fruit in their diet, and they provide a model of behavior maybe for some of the earliest hominoids. The hominoids, of course, being the apes. And we are amongst those. So looking at some of the monkeys like baboons that have a mixed habitat and a broader range of diet give us an indication of what maybe some of our ancestors might have been doing before they split into the apes that we find ourselves in. So we are hominoids, and that is our closest group that is still alive today. And these include chimpanzees, bonobos, orangutans, siamangs, gibbons, gorillas, and they're found, a lot of them are found, chimpanzees, bonobos, gorillas are all in Africa, but gibbons, siamangs, orangutans, are found in Asia. And so this is going back to what I was talking about, how there was some dispute as to where our ancestry was, and it was whether we were closer to an orangutan or to a chimpanzee. As it turns out, we now know that it's the chimpanzee that is our closest relative, and that's verified through genetics. But we are part of this same group. That is our closest relation. All apes are large-bodied, large-brained, tailless primates with broad faces and the Y5 pattern on their lower molars that we saw. And we share all of those characteristics with those apes. Also, we're going to see in later chapters that you have certain features, especially of the face, because of the changing diet, that apes start to have different features in the head, including the ability to crush things with their molars. And to do that, you need to have muscle attachments that give you the ability to have a really powerful bite. And that bite isn't for hunting or anything like that. It's for crushing really fibrous plant material, like a gorilla. You don't think of gorillas are really powerful, but they're not hunters. They're herbivores. They eat fibrous plant food. They're entirely vegetarian. But they need to be able to crush that so they can digest it. And what they have is what's called a sagittal crest. You can see, I don't have one of those, a pretty good model for seeing that. And a sagittal crest is a bony, like fin, a protuberance on the top of the head that the muscles attach to give you a nice anchor to give a really good bite, a really good grip. In fact, your temporalis muscles do attach to your head, but you don't have a particularly strong bite. If you wanted to have a stronger bite, you'd have to have something a little bit more for those muscles to cling on to give you a really nice, powerful bite. And so when you see this sagittal crest appear and these molars with the Y5 in the fossil record, the earliest of these forms, the sagittal crest and the molars, actually indicate that we're now splitting off of the Cercopithecines, Cercopithecoids, the monkeys, and splitting into apes. And so those are important features for being able to tell what's a monkey and what's an ape. The apes are going to have the sagittal crest and the Y5 molar pattern. Now, we've lost the sagittal crest, but some of our ancestors had it. Also, we are... you can see from a lot of the apes that they are sort of have a body type that's a little bit more similar to us. Most monkeys are quadrupedal. They walk across the tops of tree branches, but apes tend to what's called brachiate, and that's grasping under the branches, swinging from branch to branch under them. And so this is what's a brachiation. They're suspensory, and so like a gibbon, for instance, has very long limbs and shorter, squatter body, because you don't want this big giant body tailing underneath you. Your main way of moving around is by your arms. And When you're on the ground, some apes actually, they knuckle walk. And so they're kind of at an angle. They're not quadrupedal, so they're not horizontal, but they're also not vertical. But apes, that's sort of a halfway point between where we are now today. That we're upright walkers. We walk on very specialized feet. We have long limbs because that's our main way of moving around. And so we have fewer suspensory characteristics like a gibbon. We don't brachiate anymore, but that was our ancestry. We have the ability to grasp branches and we can swing like Tarzan if we want to, but that's not our main way of moving around. But we came from a more similar to a chimpanzee or a gorilla. And you can see that the same bones are there in things like our hip bones and our leg bones. And the way that our muscles attach indicates the bones are elongated for in a gorilla, for instance, because they actually are pulling the muscles are pulling in a different direction. But when you're bipedal and you're upright, your pelvis, for instance, gets compressed and compacted because your muscles are actually moving in a different way. So the same bones, you can see that if you're moving from a knuckle walker, you'll have your pelvis is sort of at an angle and it's elongated because your musculature is directing you in a particular way. But as the fossil record shows that you start to go upright walking, you're going to have it turning vertical, connecting to legs that turn inward to provide support for an upright posture, and you're going to have the pelvis compressed because you don't want that big long pelvis pulling your muscles in a different direction. So this is some of the anatomical features of primates that give us an indication of what some of our ancestors would have been living like, and the adaptations and the environments in which we find some of these features that we possess today. Now, do we use them all in the same way that they were evolved for? No. But by looking at living primates, we can tell a bit about their behaviors and their physiology that give us the ability to see into our own past. All right, see you next chapter.